Well, so far in our financial math section, we've learned about simple interest and compound interest, and we've been introduced to annuities. In our last section of financial math, we're going to learn about the present value of an annuity and amortization. So let's suppose that you invest, capital R, which is $2,000 per year, into an annuity for 10 years with interest rate 6% compounded annually. At the end of, this should be 10 years, you would have $26,361.59. Now let's see, how much principal are you putting in? You're putting in $2,000 every year for 10 years, so you're putting in $2,000. So the $6,361.59 would be your interest. The future value, or amount A, this number right here, was computed using this formula, which we've seen many times. We know that R is 2,000. I would be what in this case? The periodic interest rate, since it's compounded annually, this would be R, 0.06, but that's also I, which is 0.06 in this case. N would be the number of times the compounding takes place, so that's just 10 years, so it would be 10, because it's once per year. And I, once again, is 0.06. The only thing we didn't know was A, so I plugged it in and I came up with this value. Well, suppose that using the same same numbers for T, 10 years, R, the interest rate, and M, which just means once per year, M is 1. Your friend wants to make exactly one lump sum payment and have exactly the same amount as you at the end of the 10 years. Well, that lump sum that is required to earn the same amount is the present value of the annuity. In this scenario, you're making one lump sum investment and just using compound interest. So this would be your one lump sum, capital P, and then the future value, we would have to force this A, this future value, to be this number up here. And if we were to do that, we would obtain the present value of the annuity. We remember P is the principal amount, and that's now going to be known as the present value of the annuity. So how are we going to do that? We're going to set the two equations together, this side equal to this side, and we know every variable. We know what R is, we know what I is, we know what N is, we know what I, N, but we don't know what P is, and that's the variable we'll solve for. So the first thing, let's just set the two expressions together. So P times 1 plus I raised to the N is equal to, I'm leaving a little space there, the right-hand side of this equation, capital R, times 1 plus I raised to the nth power minus 1 over I. So we know every variable in this term except for the capital P, and that's what we're going to solve for. So one way of doing this is multiply both sides by 1 over 1 plus I to the n power. So I'll go ahead and write this in. Times 1 over 1 plus I to the n, using a different color here, times 1 over 1 plus I to the n. When we do that, it's easy to see that when we do this multiplication, 1 plus I to the n over 1 plus I to the n. That just cancels out, gives us a 1. So this gets us P by itself. This is equivalent to saying divide both sides by 1 plus I to the n. So on the left-hand side, we get the P all by itself. That and that cancel. Equals R, and the numerator is going to remain the same. 1 plus I raised to the n minus 1. The denominator is going to be I times this expression. I times 1 plus I to the n. And that is the formula for computing the present value of an annuity. Now, there are two forms that are frequently used for the formula. This is one of them. I'll put a box around it. The next one is obtained from this by simply multiplying the numerator and denominator here by this, 1 plus I raised to the negative n. And if you remember your exponent rules, which I hope you do, we're going to use one that uses this fact. Let's just say b to the negative n times b to the n is equal to what? Well, you add the exponents and you get b to the 0, which is 1. So if I want to cancel out this term right here, the 1 plus I to the n, when I multiply the denominator by this, it's going to give me just I in the denominator. So we're going to get P equals R. We're still going to have these big brackets. Okay, what are we going to get when we multiply 1 plus I to the negative n times the entire numerator? Well, we're going to use this fact. We have a positive n, we have a negative n, so that's just going to give us 1. The first term in the numerator times this gives us 1 by this little property here, minus 1 times that. So 1 plus I to the negative n. And then we multiply the denominator by this expression, and that just makes this cancel out. Just gives us an I in the denominator. This is the second form for the present value of the annuity. These are equivalent. You can choose whichever one is easier for you. I prefer this one because the second one requires less punching in on the calculator. The one thing you must remember is that this is a negative exponent. So either one of them will work.